welcome guys. Okay, so this video is my Leetcode solving session 792, number of matching subsequence. Okay, so basically given a string s and a dictionary words, then we need to find the number of words that is a subsequence of s. So a is a subsequence of s, bb is not, acd is, and ace is also. So we have three of them, A, ACD, ACE. So we need to return 3. Okay, so there's a small another problem I already solved. If you do not know that, you can go to the previous video, or you can type its subsequence in my channel. So this problem is somehow like the reduced problem for this. Basically, somebody will give you a string, and you check whether s is a subsequence of t. Okay, so it seems like that we need to solve. We can solve this problem by solving these problems, because we can just iterate the words and check and count whether each element is a subsequence of s. And if this is, then we just count one. So we just first copy this into this. Okay, so this is whether s is a subsequence of t. Okay, and why I type this? I mean, it looks complicated because somehow it will time exist. So let me explain. Okay, so let me just first comment this. Okay, so naively, one can just use this. One can just initialize a count equals 0 and for in words, and check this, right? If for each words in a sequence true, then we just count at 1. Then we just return count. Okay, so this is the naive solution. Right now we're going to check the naive solution give the correct answer, and if you submit, then you see it seems somehow keep running, because probably the test case is very large. So you see it fails because somebody give you same numbers, so same elements. So somehow if you use this, then you don't have to use you don't have the extra space, but somehow like you always see the same sequence, and then you keep running this. Okay, so to solving this is very easy. That if we can remember that I mean if the word is if the word is already seen, then we can remember whether it's a subsequence or not. Okay, so to solve it, then we can first create a dictionary called success and fail. So for each words, if we haven't seen these words, then we just compute it, and if it's true, then we just use success to remember it. Then else, that means this is not correct, then we use fail to remember it. Then if the word is already seen in the success, that means we already see these words before, then we just add 1. And if I is already in fail, then we can just that it will be 0 or whatever. Then finally we just sum all the values of the success, because that means how many times we success. Okay, so we somehow like we exchange our time to space. So we use some space to compensate our time to make these naive implementations looks have chance to pass, right? You see, it's still very large, but still can pass this, because we exchange some time complexity to a space complexity. Okay, and I will see you guys in the next channel and next videos, and be sure to subscribe to my channel. Thanks.